The time that the bus spent at Chagville is equal to the difference between the departure and arrival times. So there we have Chagville, we have the departure time, and then we have the arrival time. So the time that it spent there will be the difference between these two times. And that turns out to be a mere 10 minutes. Not difficult. 7:45, 7:35, 35 from 45 is 10. There's nothing to it. The time that the bus spent at Chagville is 10 minutes. What is the next one? The time that the bus takes to travel from Bellevue to Chagville is equal to the difference in the arrival time at Chagville and the departure time at Bellevue. So the time that it takes to arrive to Chagville is the difference between the time that it takes to depart from this one and the time that it takes to arrive right here. Find that difference. And of course, no problem, we just 7:35 minus 6:40, 55 minutes. If it is that simple. If not, then we'll take a second look at it. We could have done that mentally by saying that from 6:40 to 7 o'clock is 20 minutes. From 7 o'clock to 7:35 is 35 minutes. This gives a total of 20 plus 35 is equal to 55 minutes. Therefore, when we are handling time, if we just use some very simple common sense strategies, then we have no difficulty making the calculation. So from 6:40 to the hour is 20 minutes, and from the hour to 35 minutes is 35 minutes. 20 plus 35 is 55. That's all there is to it. We need to calculate the distance between Bellevue and Chagville. What do we have? We have the speed. It was given to us in the statement of the problem. As a matter of fact, it is right here. 54 kilometers per hour. And we also have the time. So the distance is equal to the speed multiplied by the time, as we have right here. So distance is equal to the speed multiplied by time. So the distance is the speed multiplied by the time. That will be some great distance if we multiply 54 by 55. If we multiply 50 by 50, what do we get? 50 by 50 will give us 2,500. So what we are calculating will be greater than 2,500. And you do not imagine that we would travel over 2,500 kilometers, maybe to get to school, or maybe on a bus when it takes 55 minutes alone. Well, that is horrible. The time is in minutes and the speed is in kilometers per hour. We therefore need to convert the minutes to hours. This will be done by dividing by 60. So we will divide the minutes by 60 to get hours, and then the distance traveled will be more realistic. So 54 multiplied by 55 over 60, and then we can do a little fraction reduction where we say 6 into this is 9, 6 into this is 10, then we multiply this and then divide by 10, which is reducing by one place of decimal, and no doubt we will get 49.5 kilometers. Always take advantage of the fact that if you are multiplying by a number like 55, then that calculation can be done quite easily. You take the 5 out and use it to multiply. So if you take the 5 out and multiply, remember what we had from here is that we are dividing this by 6 and we get 9. So take the 5 and multiply by the 9, we get 45. Right. And when we are multiplying by 11, we add the two end numbers, the 4 plus the 5, and then put the sum in the middle. So if we are multiplying 45 by 11, we say 4 plus 5 is 9 and put the 9 in the middle. 495. But we are dividing by 10, so it's 49.5. There we have another take, and the one that we said we will take a second look at. Now we are taking a third look at it. Apart from the argument that we used on the previous slide, which is we are measuring against the hour. So 40 to the hour is 20, and then 35 from the hour is 35. 20 plus 35 is 55. So apart from the argument that we use, which is the one that we have just discussed on the previous slide, in carrying out the subtraction, we could have considered that 40 is greater than 35 and therefore cannot be subtracted from it. We therefore take 1 from the hours and use it in the form of 60 minutes. So we take 1 from the hour, leave 6, and then use it in the form of 60 minutes. Now this 60 will be added to the 35, and that will give 95. So now we have a total of 60 plus 35, which is equal to 95 minutes to take 40 minutes from. So 95 minus 40 is equal to 55 minutes. Like that. Kind of like what we normally do from primary school. Or primary school mathematics, if it was taught to us properly, will go a long way throughout our entire career as mathematicians, even up to the PhD level. Needless to say that on the hour side, 6 minus 6 as we have it here is 0. As we know, 6 minus 6 is 0, so we don't really need to mention that much, although we have it right here also. Can you remember how early in our instruction that we learned to do these things? No later than at the primary level. I'm just emphasizing how important it is to know mathematics or to be taught mathematics properly from the primary level. Here is our cuboid, and let's see what is required. The diagram represents a cuboid. It is a three-dimensional figure. A cuboid has all faces being rectangles. Therefore, the area of any face may be found by multiplying its 2 dimensions. That means if we need to find the area of that face, we need to multiply the h by the 4. So, area is equal to length times width. Being rectangular in shape, we have 4 times h, 4h. That's our expression in h. Also, the volume is equal to, because it is a prism, the cross-sectional area times the length. The cross-sectional area times the length. So, in finding the volume, we may look at the figure in any way we want. We may look at it as a prism and multiply the cross-sectional area by the length, or we may take into account the fact that the volume is the product of length, width, and height. So, being a prism, or a rectangular prism as a matter of fact, or a cuboid, we may take advantage of the fact that we can say area times length, which is cross-sectional area times length, or we may say the volume is equal to length times width times height. However, the area contains 2 of those dimensions already. So the area would have contained the width and the height already. And this is the area. So all we need to do is multiply by the other one. So for the volume, length times width times height. But the area contains the length and the width already. So the area contains the width and the height already. Therefore, we just multiply by the 13. So we have 4h times 13. 13 times 4 is 52. We have 52h right there. We have the formula for the volume of the cuboid right here. In finding the height, we need to make use of the equality. What equality? we are supplied with the volume in the statement of the problem, and we have the formula for the volume right here. So we equate the formula for the volume with the value of the volume that is given to us in the statement of the problem, and we have 52H is equal to 286, which is the volume supplied in the statement of the problem. In finding the height, all we need to do is eliminate the 52 from this side by dividing, and do the same thing on the other side. So we will have H is equal to 286 divided by 52, and that will turn out to be 5.5 centimeters.